Welcome to today's webinar entitled, Will Your Building Survive? My name is Billy Zadek, Manager of Special Programs for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA webpage under the Continuous Learning tab later today. Professional continuing education certificates are being offered for today's program. Those who indicated they wanted a certificate at registration and meet the requirements will receive certificates later this afternoon. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by one of our presenters. Before we get started, I would like a little time to introduce our speakers. Eileen Mason, founder and CEO, Rethinking Power Management. Eileen started Rethinking Power Management with a vision of reducing the impact of climate change by helping commercial clients turn an interest in energy conservation to sustainability into realities. Previously, Eileen worked for the Consortium for Energy Efficiency, organizing utilities, government entities, manufacturers, and other stakeholders in support of efficiency-related market transformation initiatives across the U.S. and Canada. Steve Murphy, Senior Engineer at RPM. Steve has broad experience in various industries. His expertise in electrical power factor and power quality, lighting, and control system has benefited companies in both private and public sectors. He brings a unique perspective to RPM clients, having been an in-house engineer and consulting engineer. The common thread throughout his career has been a passion for sustainability. And Nick, I apologize. I don't have your bio. I didn't put it in my notes, so would you please introduce yourself? I'm going to turn this over to everyone to get this presentation started. I apologize, Nick.
My name is Nick Durr. I'm a third-generation builder. I'm an architect by training, and I'm a senior leader at Canon Design's FOSS, that's Facility Optimization Solutions Group. I have about 20 years of experience, and I'm focused in my career on facility management services and helping folks take care of their existing buildings. If I could just get a thumbs up that we're advancing the slides. Everything's working. Great. Thanks, Steve. Okay. Thank you for the intro, Billy. We're pleased to be here today to talk a bit about climate resiliency assessments, some national trends that we're seeing, our own business models, and how we're helping our clients in the higher education space with this. And I'm going to start with Facility Optimization Solutions, just so you understand who it is that we are and what our experience comes from. We're part of Canon Design. We're essentially the facilities team inside of Canon Design. We've worked in 37 states, 3 Canadian provinces, providing facility management services. We're currently ranked #1 in the world for FM services by an AE firm. We've done over 1 billion square feet of condition assessments and capital plans and strategic plans for our client partners. We have a 100% client satisfaction rating. We're a diverse group in terms of our mindset and our backgrounds and experience. So we're made up of architects, engineers, former constructors, construction cost estimators, facility management and maintenance engineers, and software developers. This team was built this way very intentionally to make sure that we're bringing the right types of interdisciplinary expertise to facilities management practices, to make sure we're taking it from all of these angles and not having a single focus, but instead bringing everyone to the table. So in terms of the way that we do our work, we have 2 types of services to help people plan with confidence, benchmark both the quality of space and the energy associated with that space, and then to mitigate risk and invest wisely through data. We're also a software company. We have 2 platforms that we currently operate for our clients. One is FOSSCore. This is our capital planning, data collection, cost estimating, and reporting platform. And SimpleBid is our job order contracting, rapid construction procurement platform. We're also developing a TCO platform, which some of you may have seen our app presentation previously last year. If you want to know more about that, we can refer back to that presentation.
Thanks, Nick. I'll just do a quick introduction of RPM. So we are a mission-driven sustainability consulting company headquartered in Boston, Massachusetts. We provide strategy and engineering support for owners and managers of either portfolios of buildings or complex buildings. And we like to be really serving as their internal resource, getting to know them, working together with them over time to reduce the environmental impact of their buildings. Am I advancing the slides, or there we go? How is that going to work, Nick? Will you advance them?
I'll advance them, just let me know.
Great, thank you. So we're not installers or contractors or product providers. Rather, we provide support for short and long-term planning, goal setting on securing financing and incentives on the strategy side. On the engineering side, we really are focusing on energy and lately decarbonization audits, project conceptual design, energy and benchmarking services, owner's agent services. I like to think of us, if you can slide to the next one, I like to think of us as a very practical partner, thinking about a client's business as well as their buildings and helping them execute a plan for the future. Next.
Thanks so much, Eileen. So I'm going to start with some big picture thoughts, some national thoughts, starting here with the science. Really, we all know this. I'm not going to go through this in detail, but what the difficult challenges and the problem statement is taking the science and turning it into action, dividing this up into actionable plans, how we move this forward, and what the goals are, understanding the goals from an institutional perspective and a state perspective as well. So really one of the big things that we know about this data statistically is it's leading to an increase in the number of major weather and climate disasters. That's drought, flooding, hail, hurricane, severe weather, tornado, wildfire, and others. Really, the point that I want to make here is that we know we have the data, we know this is on the increase, we know the cost associated with this. This is a three-legged problem, and one of those is the economics, the simple cost of the damage for these types of events that are increasing around the country. So my hometown, Buffalo, New York, we had a pretty major snowstorm this past winter, just after January. If you look at that black line on the graph, that's the average over the last 42 years. So less than $2 billion events on an annual basis. Now, if you look at this year at the top, you can see that we're averaging more like 6. So what we're seeing again is an increase, and this is a community that's impacted. This is was a national disaster. It was a national emergency. There was a loss of life. There were heroes in the community as well. But the second leg of the problem is the public safety aspect. So we have the economics, we have the public safety aspect. And then flash forward to today is the wildfire plumes that many of us are seeing coming over the border, and that is affecting the air quality index and our overall health. So again, these have an economic, public safety, and public health impact. And it's these three problems that really start us into defining and understanding where each state is, and also what we mean when we talk about resiliency. I'm going to spend just a minute or so on this map, and essentially the quick takeaway would be the states that are in white are either your least restrictive or your least progressive, depending on which state you're in. And your states that are in green are your most restrictive or most progressive, again, depending on where you are. So states that are in green have a 75% energy reduction in greenhouse reduction by 2050. States that are in yellow have just the energy, and states in blue have the energy efficiency standards only. States in white do not have a published standard at the time of this data. And this is from the National Regulatory Research Institute. Additionally, a little bit more information on which states have adopted either or a 100% goal by 2050, and that is in the circle or the square. So again, a square would be 100% for both energy reduction, clean energy, renewables, as well as greenhouse gas reductions by 2050. And then taking this all together to move forward, how are we defining resiliency? How does resiliency play a part in this set of problems? The simplest and clearest published definition that I found is the ability to anticipate, absorb, accommodate, and recover from these events.
Great. So with that kind of national framework, what we're going to focus on today is really talking about how Massachusetts is approaching resilience planning, and we're going to do that in two parts. First, a bit about the policy that we're doing, and then a bit about, and then more about how we're actually applying those practices and approaches for state-owned universities and community colleges in Massachusetts. So as Nick mentioned, we've all seen the impacts of climate change, storm surge, droughts across the country, wildfires, air quality, hurricanes. We've all experienced it. You can go to the next slide, Nick. In Boston, what we're seeing two really large kinds of impacts that we haven't seen before. One is storm surge, where we're seeing boats down the middle of city streets, things floating down streets that shouldn't be. The next, and a lot of damage to the economic factors that Nick mentioned, as well as public safety. If you can go to the next slide, Nick. We're also seeing a really big increase in extreme heat. Last year, we had several periods where we were seeing temperatures over 100 degrees, which is really not much in Boston's historic record. There we're really talking about public safety, public health, as well as economic damage, especially as it affects farming and those kinds of industries. Next slide, please. So against that backdrop, Massachusetts is taking definitive steps to both reduce carbon emissions to lessen long-term impacts, and also to create resources to help prepare for what's to come. We're hoping that the frameworks and the approaches that Massachusetts is taking that we're presenting today can be helpful for everyone in identifying and prioritizing the environmental risks in your region and at specific sites. So if you can go to the next slide. Just to set the stage of what's happening in Massachusetts. So the state has set a goal of reducing emissions by at least 85% by 2050 and achieving net zero emissions in that same timeline. So to do that, they pulled together a number of stakeholders and developed this decarbonization roadmap. The goal of the roadmap was to provide the Commonwealth with a comprehensive understanding of the necessary strategies and transitions in the near and long term to achieve net zero by 2050. In other words, how can the Commonwealth achieve net zero while maintaining a healthy, equitable, and thriving economy, right? What are the financial implications? And this report is actually very readable. It talks about the conditions that and the factors that went into the planning, and I think it's a great resource for anyone who's looking to do this kind of planning in their own communities. A second area that was addressed in Boston were the building codes. These were updated last year. So there are now 3 building codes in Massachusetts instead of 2. There's a base code, there's a stretch code that has extended energy efficiency and other requirements that communities can opt into in order to access state funding and grants. And the third one, which is new, is an opt-in specialized code, which actually starts pushing towards passive house for new construction projects. About 17 out of the 351 municipalities in Massachusetts have opted into the specialized code. And then the last, so the specialized code is really looking forward into new construction, whereas we've also enacted something called BERDO, or the Boston Energy Reporting and Disclosure Ordinance. That's really looking to affect existing buildings. So in addition to having mandated energy reporting, in Boston there's now an emissions cap that takes effect in 2025. And that cap is different for different sectors, so different for multifamily than hospitals or higher ed. And it ratchets down to 0 in 2050 to meet the state's goals. So that's really driving a lot of focus on decarbonization and planning, which is bringing a lot of money into that work. And it's not just Boston, but a lot of other municipalities in Rhode Island or in Massachusetts are looking at the same thing. So that's what's happening on the mitigation side. On the adaptation side, if you can go to the next slide, what we're seeing is this effort called Resilient Massachusetts, and the website is there. All these resources are available. They've really they've focused on 3 initiatives. The first one is this Municipal Vulnerability Preparedness Program, and that's really focused on providing support for communities to identify climate hazards, assess their vulnerabilities, and develop action plans. So it's financial support. There's actually grants available to do that planning. The next one, I don't know how you would say that acronym, the State Hazard Mitigation and Climate Adaptation Plan. And that's looking to integrate climate change impacts and adaptation strategies with hazard mitigation planning. It also allows the state to comply with federal requirements and access federal funding. And the third one, the Resilient Massachusetts Action Team, these are all really mouthfuls to say. That one is sort of the watchdog group that's looking at how these plans and these initiatives are unfolding in the Commonwealth, and then trying to make recommendations and adapt them in real time. So as with most states, Massachusetts is trying to fly the airplane at the same time that they're building the airplane. So it takes a lot of watching what's happening and seeing what's going on the ground. And I want to mention this RMAT team because one of the tools that they developed is something that we use a lot there. We call it the RMAT report, but it was used very extensively in doing the assessments for the higher ed facilities in Massachusetts. So if you can go to the next slide. So as I mentioned, the mandates that we're seeing to decarbonize and the funds that are flowing in from different areas are really focusing attention on decarbonization. What we're seeing that's what we're seeing in the private sector. And what we want to make sure is that as these funds flow in for decarbonization, that we don't forget about the resilience planning, because there's a lot of money coming in, and a lot of the efforts that are going into decarbonization can also support resilience adaptation. So we find owners that are interested in looking long-term at their assets and investing in their assets. Major renovations, not only to the buildings, which is important for resilience, but also sometimes to the grounds and the landscaping that's happening around them. Looking at utility infrastructure, and we're seeing a change in the way owners are thinking about investing. So when you think about something like energy efficiency, it had a quick ROI. You invest in LED lights and it pays back in 3 to 5 years. What we're seeing on the resilience side and on the decarbonization side is that the interventions are much more expensive. And in order to make that pencil out, we're looking at these funds coming into the industry, but we're also seeing that the fines that are being levied for organizations or for buildings that don't need emissions cap are also changing the way owners are thinking about addressing resiliency. So with that, we can go to the next slide.
Thanks so much, Eileen. So we've been kind of zooming in and zooming out, and we're going to talk more about our specific work in Massachusetts. I wanted to zoom back out and talk about nationally. So nationally, there's not today, and please, if someone does have new information, please put it in the chat or direct me to it. There's not a existing resiliency assessment guidebook or platform. We do know, of course, that ASTM is developing this now. It is a work product item. I believe that the first draft has been completed. This is coming. Again, there's various states that are doing this work differently. We have a lot of experience in Massachusetts with their higher education portfolio, and I think that Elaine's metaphor of building the airplane while you're in the air is very apt. And again, we know this is coming. We don't know exactly what it's going to say. I imagine it'll be in committee a bit longer, but this is something that's going to be very important for multiple industries, including higher education, insurances, communities, municipalities, to have this information as planning data, as table stakes planning data, to understand how they invest in their facilities and how those facilities will adapt and absorb, and what their risk is in the event of a storm, and whether or not they can be occupied, and how they'll help the community during those events.
Great. So with that, we're going to pivot to the case study, really looking at how did we do the assessments for higher ed facilities in Massachusetts. So I'm going to talk a little bit about some of the high-level planning, and then Steve is going to dig into how it really unfolded on the ground and share some of those resources. So we can go to the next slide. As we think about assessing environmental risk, and the way we're thinking about it, we divided it into really two buckets of risk, right? So there's location risk, which is to look at location risk, we use this RMAT report or RMAT tool that was developed by the state. And that uses some GIS maps that the state developed that have projections on what temperatures are going to be, what rainfall is going to be, looking at different environmental impacts and what that looks like going out to 2050. And using this state developed tool, we were able to say, okay, here's our region within the state. Here's what we're seeing. You answer some other questions like that have to do with how the facility is being used, that kind of thing. And the tool assigns a risk factor, low, medium, high, to these 4 risk categories: storm surge and sea level rise, stormwater, extreme precipitation and what that does to stormwater management, extreme precipitation and how that affects groundwater, whether it's in-ground water or local lakes or ponds or rivers, and extreme heat. And those are really the things that we're seeing the most forward-looking risk for Massachusetts. And with the tool that the state developed, we're able to do forward-looking projections. If you use some of the federal tools like the FEMA flood maps, those are all based on historic data. But the nice thing about this tool is that it allows you to look at what's anticipated to come, what the science tells us is coming down the road. So that's the first part of our assessment. The second part, we're looking at the built environment risk. And this is looking at existing conditions and how capable are they to meet the risk that we see coming in the future. And as we look at that and look at the vulnerabilities that we see, those really fall into categories like the building vulnerability, how susceptible is the building to moisture penetration or to mold and those kinds of things. Infrastructure vulnerability, which has to do with stormwater management and utility infrastructure. And then a population vulnerability, which gets to how is the building being used, and who does it house, right? Is it a hospital? Is it a dorm that houses students that are there 24 hours? Is it a facility that can be easily shut down? So really looking at how do the future risks play into how the building is used and what it looks like. And that gets to today's conditions. So how do today's conditions meet future expectations? So if we go to the next slide. And the way we're thinking about it too is what questions are we trying to answer with this assessment? What are the high-level questions that planners who are looking at asset management, is this building going to be capable of meeting future need, or capital investment, what are the kinds of questions that they're looking at? So I think the first one is how critical is it to maintain operations in this building? And that gets to how it's used and its populations. What's their stormwater management? And that gets to access. If you have to evacuate, can you? If you have to shelter in place, what happens then? And flooding kinds of concerns. Utility infrastructure, we're looking at things like redundancy. Do you have multiple feeds into your campus for your electric service? How vulnerable is it to disruption? Looking at backup power, what is powered and where, and is that in the places you need it? Is it sufficient? Other risk factors like hazardous waste. If you're at higher ed, do you have an animal lab that you have to be concerned about animals there? How again is the building being used, and what other factors do you need to consider? And then, as I mentioned, building vulnerabilities, which is what we typically think of first and foremost when we think of resiliency. Water infiltration, mold issues, those kinds of things, either from groundwater or from storms or sea level rise. So that's sort of the high level framework about how we're thinking about it. And now I'll turn it over to Steve to talk about how we actually do it.
Hello, everyone. When I get notified that I have to go out and do a resiliency review, one of the things I look at obviously is locations. And with the Massachusetts higher ed and community colleges, they have places situated all over the state, but each of them has unique location factors that affect basically our whole climate resiliency. For instance, you see a picture there of one of the institutions. It's right on the water. You know, there are a lot of things that I have to take into a factor when I look at a facility like that. Look, I'm looking at as Eileen had said, the GIS mapping. I'm seeing, does it qualify into a FEMA flood zone? So that tips me off right away. So now I'm going to, when I go to that facility, I'm going to be looking at different things. I see one in a very rural setting there on the left-hand side, another facility. There's different factors involved there too. What are the elevations of that rural factor? Are they susceptible to like a flash flooding? How is the campus laid out? And what are the, do they have island heating and things like that? And then last but not least, as Eileen was talking about the storm surges and things like that in Boston area, we see one in a very, very, very rural city type of setting. And some of the big factors there are, is the utility that handles the sewerage and the stormwater, are they in and surrounding the campuses, are they up to grade? Are they working effectively? Does their inability to maintain their system have an effect on that campus? So I take all these into account just right before I go out. Next slide. When I get ready to, just prior to going out, I do a lot of what we call web-based research. As you can tell, I can get a good sense of what I'm going to be looking at using Google Earth. I like the fact that you can get right on the roadway and take a look at a side of a building and so on and so forth. But I use that. One of the best tools, though, is the MassGIS map and the FEMA maps. They tell you everything. As Eileen talked about, we are currently working on a database which collects all of the data that I see into one area for Massachusetts in the DCAM. And so what happens is they get all of that information and they're able to make all kinds of great decisions based on all the data that we pull in. I look at some of the site resources. One of the big things that higher education and campuses sometimes don't take into effect is if something very simple, if you're putting in a walkway, what sort of effect does that have on climate resiliency? Do you pool water where you're not supposed to pool water? Does it seep down into elevator shafts? Does it seep down into, basements? Does it affect equipment? All of these things. I look at maintenance records. What are the red flags here with some of the maintenance things that happen? And then I actually go on site or prior to that, sometimes having a meeting, and I ask all kinds of questions based on climate resiliency. And I'll go over that climate resiliency checklist in a little bit. But I just ask a lot of questions in a conversational way. I almost put on my facilities director hat and ask them, all right, what are some of the things that are bug you? What are some of the things that you have to always go into? I mean, is that sump pump always breaking down? Things of those natures. So it's great. Then the next thing I do is I go on site And I already have a pretty good map of what I'm going to be looking for based on the interviews, based on what I have for the web source resources, based on some of the things that I looked up in the MassGIS. I have a really good roadmap of what I'm going to look at ahead of time. And one of the first things that I really go after is I look at the moisture damage around the building foundations. Now, if you've got a 1970 or early 80s structure that has what we call a French dam or compressed rocks around the foundation, those things I look at very, very carefully because, believe it or not, those break down and they create crevices, which then seep the water into the foundations. And that causes all kinds of problems. Causes mold, as you know, but it also causes vomit infiltration. It sets the temperature differential within the foundation, so on and so forth. So there's a lot of different things that I have to look at. And the other things I look at is soil erosion and other signs of some severe washout. If you're in an elevated area, if the campus is in an elevated area, this flash flooding. What happens if you have, like Nick in Buffalo had a large amount of snow? What happens if the higher elevation campuses in Massachusetts have an increased amount of snow? What's going to happen during melt period? All of these things that I look at and try to picture a potential problem with those. Hardscape cracks, foundation walls that are starting to crack down, that are starting to break down, any types of major cracking that I see in any of the structures that are a result of any type of water damage or stormwater damage. And then the last thing I look at is the electrical infrastructure and how important it is. Eileen touched on this a little bit earlier. Does the facility have a backup feeder? Does it need a backup feeder? In utility companies now, they want to provide the most reliability as possible. Does the institution require a backup feeder? Very least, if you have a feeder from the electric utility that's fed from a substation, does it have two feeds to it? And if one goes down, does the other one automatic throw over, and so on and so forth? Is your facility critical enough where you require a feeder from different substations, from different transmission lines? I know, based on the work that I did in downtown Chicago, where they required backup feeders in the same substation, but from totally two different transmission lines, from two different areas. That's how critical it was. These are some of the questions that you, as facility directors, planners, or whatever it is, have to ask yourself. How can you sustain a 1 week, a 2 week outage? Can you sustain a transmission line going down, and so on and so forth? So with that all in mind, next slide, please. I get into, next slide. I'll show you, these are some of the examples that I've seen out on the thing. We can go through this. I talked about the water damage based on, some sort of soil erosions, evidences of washout. Why is this important? Hardscape cracks. Are you seeing some of this on your facilities based on water moisture buildup and not going anywhere? Next one. And then this, we can stay right here. This is the stormwater or electrical infrastructure. So the key to this is, and what we're going to do is, when I go out, I'm going to capture all this data. I'm going to capture those areas where it requires some pumps. I'm going to really get into the areas where you have equipment that's below the water line, where you have equipment that is within a flood zone, close to a pond, close to a lake, reservoir, and things like that. And I'm also going to look at the electrical infrastructure. If you have a major storm and you're taking on water and you don't have any power, that's a big problem. That's a really big problem. And so what do I look for in the foundations when I'm down there? I'm looking for staining. Do you have a 2-foot stain? Do you have a 4-foot stain? What's going on in this facility? Next slide, please. So some of the tools and resources that I use, and we're going to get into this very well here, is what Eileen had talked about earlier, is the RMAT report. And this is a report that we create using the Resiliency Massachusetts assessment tool. where they ask a bunch of questions, and based on my observations out in the field, I answer that and put it into the report. I also add in some narratives, which I write out when I see any deficiencies or any potential problems that that can occur or have occurred and that are important to the resiliency study. This resiliency assessment tool also takes in what I talked about earlier, which is that Mass GIS map. So what we've done is we've created a database now, which this RMAT report and this resiliency tool database, both are in sync. So they're pretty much a type of report that can any facility director or anybody can utilize and get a really good idea of where you are as far as in resiliency. Next slide, please. Now we get into the nitty-gritty. So as part of this RMAT checklist, which is now on a database, what are some of the questions that I want to find out is, who's your utility supplier? Are you a regular national utility supplier, or are you a local supplier, and so on and so forth? I want to find out who your natural gas supplier is too, and this is very important. Water and sewer, getting that information. Is it the town, or in Boston, is it the MWRA and things like that? The next the thing I go through is I look at all of the data and I find out what your peak demand is. And I look through a period of 3 to 4 years and I find out how much usage and do I see any trends in that usage. How important is demand? Very important. Not only does this have a tracking tool, which you can then find out, okay, what's happening with my facility, but you can save so much money too. If you find that you've got an anomaly in a peak demand for your campus, you're paying a lot of extra money, to these utilities, because basically, as you all know, the demand is what the insurance is with the utility provider. So if you have a peak demand that's a one-time year event where something happens, they've got to provide you with all the utility infrastructure just for that peak area. Where in reality, maybe your load or what your constant load is maybe half or 3/4 of that. So that's very, very important. We're also pulling in who your telecom people are, who your fiber your company is. We put that all down in the report too. Now we're getting into some other issues where we're trying to calculate how much gas, what's your gas usage per year. So I look at the database that they have put together, and they're working on pulling all of that data in from all of the facilities and having it going into this, what we call the DCAM database, to pick up what the maximum or the peak heating is. This is very important also, because this will also be able to track if we're taking an electrification type of approach to this. Can we keep the peak demand down while we're implementing electrification? And can we track how low now the peak heating is going down? So that's part of the decarbonization that they were talking about earlier. And the same thing with the peak cooling. If the campus is in a high heat zone, which Eileen had showed a map of, say in and around the Boston area, and half the buildings are cool, by 2050, you really got to start looking at what are we going to do about cooling or increasing cooling and so on and so forth. So this is very key data, not only for looking at it or forward thinking, but if you've got a chiller that's perhaps beyond useful life and you're thinking about changing that out, you can go to this database and say, all right, let's look at our peak cooling and where are we at? Are we at 100% already? Maybe we should start thinking about maybe increased tonnage, going down the line in order to pick up some of these climate resiliency things. Now, if you don't have a backup feeder and you're working on one feeder, what kind of backup emergency power system do you have? I gather this information is very, very important. does the campus require you, some of the things that you should think about is, do you require to go full power backup, or do you require just life safety and emergency? How often is your campus, occupied? And these are some of the things that you should probably look at, and this is some of the data that we collect so that you can do some of that forward thinking. And we get, the generation output. We look at how many units that you have. Very important, what kind of fuel source do you use? If you're running a diesel, generator, and do you have local agreements with the fuel suppliers so that if you would sustain a longer outage, are you going to be able to take that all on? And are they going to be able to fill up your tank? So, and some of the other things that we look at is the battery storage, and we get all that information based on what you have for battery storage capacity. Next slide, please. Like I said, the MassGIS takes a lot of this information and pre-fills it into this DCAM database. And they give you the annual max temperatures that you see 2050 that Eileen was talking about, the projections. It gives you a great idea of number of days per year over 90 degrees in 2000. Why is that important for me? Well, I just want to see that it matches up with what location that I'm in. For instance, as you saw on the map, if I'm out in northwestern Mass, where they only had maybe 1 or 2 or 3 90-degree days, then I look at the facility and how it's all laid out as far as cooling goes. I can see why, okay, this is why that only half of the building is cooled, or this is why, that they don't have, cooling in this part of that, and so on and so forth. So it sort of gives me a sanity check as to what's going on, and this is a great tool to use that for. Does the, what's the maximum outside temperature which the system can maintain a set point of 75 degrees? That is also what we call, the design build cooling factor. That is pretty standard. I think Massachusetts is in zone 5, so that's pretty standard, 84 degrees all the way through. I also look at the rainfall, and this is very important too. If I'm looking at the stormwater infrastructure, can it handle 5 inches an hour? Can it handle 2 inches an hour? Those are some of the things that I look at and see, do they have things in place that can handle a mad rush of stormwater? And some of the other things that we talk about, I look at infrastructure to see if there's a lot of paving cracking, where has water been, within the last 5 years. You can see it right in the facility. When I'm out doing site facility, I walk the whole facility. I do all the borders. I find out what's going on in and around the facility. Next slide, please. Now the other, this is probably, and this is probably going to end up with the last piece of this, but this is really critical, and this is really what DCAM wants to know. What equipment is below or is in the flood zone, and how can you start thinking about getting it out of there, pretty much, if you can. And you can do this with some project planning. But what I have to do is I find out any equipment that's within 20 feet of, if they have a pond or a type of lake next to it, if it's within 20 feet, I have to put that into the database. If any equipment is below the water level, I have to put that into the database. DCAM, or the Higher Education and Community College of Massachusetts, they want to know what's at stake here and what is critical. And I do believe that, in time, as they go with the, project planning, they will go ahead and, make some moves to get that equipment out of that flood area. You can't predict sea level rise. You can't predict storm surge. You can't predict, any type of long-term flooding from the sea, Mother Nature. So prepare for the worst, and the best is probably looking at trying to get that equipment, away from any of those areas. So with that, I hope I covered some of the on-site research that I do when the boot's on the ground. Thanks.
Thanks so much, Steve. And one of the things that I wanted to really, again, zoom back out is to talk about how this work, and it's ongoing, is done with multiple lenses. So it's the resiliency aspect that was conducted in parallel with a facility condition assessment that was conducted in parallel with an ADA assessment. And the reason that this was done is because realistically, the changes that need to be made are at the equipment level. So having the interface between the equipment replacement schedule, the equipment condition schedule, and the resiliency needs to make sure that we're integrating those decisions and that thought process in tandem is really what made this project stand apart in my mind, that integrated approach to have all three of these together in parallel in terms of prioritization planning. Again, the focus of this topic is resiliency, but tying that to the work that's going to be done is really important. So not just having the data, not just having the planning and the study, but how do we implement this at the building level to talk about campus level improvements. So I wanted to open it up to questions in just a moment, unless Eileen, you had anything you wanted to add as we wrap up the presentation portion.
No, I think the only thing I would like to say is that the intersection between the facilities assessments and the resilience assessment was really critical to all of this. So having that back and forth with people who are really diving into the ADA and the facilities condition, I think really made the resilience assessments much more robust than they might otherwise have been. So I just want to echo what Nick was just saying.
Good point. Yep.
Okay, I think I've suspended my screen sharing. I think it's just us now. And I think our protocol is to put any questions you might have for this team in the chat. And we'll do our best to answer them.
So while we're waiting, there is one thing that I'll mention. If others have questions, please put them in the chat. But there's another aspect to resilience that we're not talking about, and that's emergency preparedness planning. So I think that's also something that I just want to mention in passing. As you look at, what steps do the humans on site take in the days leading up to an event, during the event, and in recovering from the event. So I think that's another aspect that people may want to consider as they think about resiliency planning.
Quick housekeeping, everyone. I don't believe we have the power to unmute you. So if you have a question, please throw it into the chat. There's even a questions tab specifically you can type your questions into, and we'll be happy to read those out loud and get them answered for you. Okay, here's one. Is any size body of water cataloged, even if it is just a pond?
I think that's a good question for Steve is, what is the cutoff point for documentation for a body of water?
I look at, as far as documentation for a body of water I'd have to see the water. I mean, I come across a lot of low-lying areas which are used as what we call retentions for extremes and for evacuation for extreme water flow and rainfall flow. But a pond which has a pretty active spring and it's sustainable and it's been there for a long time, that's what I classify.
We have another question that says, can these resilience assessments be completed by the FCA staff, or are they done by the third parties?
Great question. So I'm going to start with that. The short answer is that you can do it both ways. We look to RPM for their expertise and the scale of this particular project. I think that it can be done by the FCA team, but realistically, this is such a specialty service that I would encourage those teams to reach out to a group that has the depth of knowledge, that has the, their finger on the pulse of the industry, because it's something that's rapidly changing. So I think there's an opportunity for that, but I would recommend, making sure that your team in whatever format has all of the experts on board to make the right planning and data documentation, because in most cases, we're really talking about defining where we are now, because in order to measure and track improvement, we're setting the benchmark, and that would be my recommendation.
Another question says, do electric vehicles and charging stations affect your work?
Go ahead, Steve. How are you accounting for those?
So we do look at where the charging stations are, and finding out they're usually in an elevated parking lot. What I do is when I look at that parking lot with the charging stations, I look for the electrical infrastructure that supports that charging station, which is usually a pad mount transformer. But what's more important is the parking lot capable of diverting water, or any storm water, or any type of flash flood water away from those facilities. And so what I do is I take pictures of drains, I look at the drainage system and where the elevations are.
If you had to address a shortfall of campus resiliency, what would you address first?
Really?
What was the question?
It says, if you had to address a shortfall of campus resiliency, what would you address first?
So if you had a shortfall. So I think what I would look at is the magnitude of the risk and the likelihood of the risk. So, for example, I think if I interpret the question correctly, you're saying, like, if you had to address a flooding situation and also a lack of cooling situation, I think that's kind of the question. And how do you know which one to address first? I would look at the likelihood and the magnitude of the risk and how many people would be impacted. And then I would make the decision that way. I think another way to look at it, another lens, is, are there other projects going on the campus that could impact or make it easier or harder to address something now? Or is there something coming up in a year that you're planning to do? For example, if you know you're going to be upgrading your boiler systems or your lighting in a facility, that's going to help your ability to shelter in place or something like that. So I would look at it based on magnitude of risk and on other planned projects that could support some of the work that might need to be done. I hope that answered the question. Other thoughts, Nick?
Yeah, I just wanted to add sort of a different tactical lens, and I totally appreciate what you said from a big picture, risk management standpoint. I would start, if it was my campus, in terms of power. So I would start with backup power as my number one, and then understanding, as Steve said previously, what buildings are people living in? Your residence halls, I think those are the ones that come to the top. And then any existing relationships you have with communities. So is the outside community expecting to use an athletic facility during a climate disaster or an extreme event? So I think that the big picture risk is absolutely there. That's going to help you focus your approach. And I think really the other thing that Steve said that resonates with me is, how many days could you really go without power? And thinking about that passive occupancy aspect, and again, back to the students. So the only thing worse than having a building down with 200 students in it is getting 200 phone calls from their parents.
That's good.
That's really true, Nick. Thank you. That's great. Yeah.
We do have another question. It says, do you see the value and would you encourage participation in community emergency response team or other FEMP programs?
Yes.
Nick, I'll let you take
Yeah.
that one.
Absolutely. Plan ahead.
Yeah, the more community people, they have a lot of also resources that can help a campus, a higher education campus. And there's probably the higher education campus has some tools and has some resources that can help the local community as well. You know, you don't know where the specific areas are going to be flooded, or you don't know how bad or how long the outage will be, and so on and so forth. So I think it's the community spirit is going to help alleviate the disaster.
What we've seen in multifamily is that there's a lot of coordination with community resources, both in terms of evacuating residents, understanding, you know, what help there can be for that, as well as if you're a shelter and the community is planning to rely on you, but also, you know, understanding who to call, what kinds of phone trees you need to have, and what kinds of communication channels, who's going to take the lead in that, and who are they contacting. It can also be really critical in an emergency.
Now we're coming up on the end here, but we do have a couple more questions. This next one says, how frequently should the data be updated due to campus changes?
Nick?
On the condition side, I would say every 5 years, or have a program where you're in a state that you're making updates as projects are closed. But again, I would defer to Eileen in terms of resiliency and planning. How frequently do you think that needs to be refreshed? I mean,
You know, I think the 5-year rule is a good one, but I also think you really need to keep an eye on what's happening with your buildings, because you may have vulnerabilities that get worse with time or that degenerate quickly. So I think, you know, as a general rule, I would say 5 years, but I think it also needs to be informed by what's happening on the ground. Steve,
Yeah,
do you want to add?
Yeah, I like your 5-year check-ins. I do think, but with climate resiliency, I'm looking at maybe a semi check-in after 3 years. If you're using a 5-year planning capital budget tool, that's great. But you know, like a 3-year review, just a sanity check, just to see, make sure that everything's moving forward and you're up to date with everything.
And the other piece that's changing rapidly is the funding that's available for these kinds of projects. So I think that can sometimes be a driver. So keeping your ear to the ground in terms of federal funding, especially through some of the large bills that have gone through recently for decarbonization planning and for resilience. I think keeping your eye on that can also help inform when you may want to revisit, because there may be funding available to help you do some of the things you want to do. Understanding what you want to do is also kind of critical, and there are, and I realize we're just about out of time, so I'll stop there, but there are tools to help you figure out what to do when you find these deficiencies.
one more question there.
There is just one more. When we replace emergency generator, should we select natural gas or diesel fuel source through the lens of resilience?
Oh, that's a great question.
Great question. I'm seeing if available now, I'm seeing a lot of natural gas hookups, getting away from having a tank, having to have it filled during an emergency situation, and having to treat the fuel oil, you know, on a regular basis so it doesn't go stale, and all those things. In decarbonization, you know, which is the lesser of the two, you know. So I'm seeing a lot of natural gas.
I've pulled enough tanks to never ever want to put one on the ground, because once that soil is stained, you chase it forever.
Yeah.
That's not an energy consumption answer, but it's a practical consideration.
Mm-hmm. Exactly.
And going forward, what we just saw in Massachusetts was the first battery backup generators installed. So that's not in most jurisdictions code codes yet, but it's something that looking forward may become more common.
Really appreciate everyone's time, and I hope you can see our contact information still up on the screen. If not, it'll be in the package that's available for all of you. If there's any follow-up questions, we're happy to continue the conversation.
Thanks, everyone.